Hello friends, welcome to the session on influence line diagram. So today we will take up the problem on multiple point load. A loading system of 120 kilonewtons, 150, 160 and 80 kilonewtons with spacing of 2 meters apart crosses a girder of span 25 meters from left to right. 120 kilonewton load is leading. Determine reactions, absolute maximum shear force and bending moment at section x is equal to 8 meters from left. So this is the girder. The required point is here x. So this value small x is equal to 8 meters. L minus x is equal to, so overall span is 25. So 25 minus 8, 17. So these are the four loads and these cross the girder from left to right, and spacing between them is 2 meters apart. 2 meters is the spacing between each of the loads. Now as usual we'll start with the reactions first. Reactions. Under that ILD for RA. Now usual procedure, let this value be. Now you have to place this loading system. 120 is leading. You have to place this loading system here. Last load should be here. 1, 2, 3, 4. This is 120, 150, 160 and 80. Its value, standard value is 1. Let this value be y1, y2, y3. Now this overall dimension is 25. Distance between each of them is 2, 2, 2. This dimension is 19. 25 minus 6, 19. Now calculate y1, y2, y3. y1 divided by 19 is equal to 1 divided by 25. So you have, next calculate y1, y2, y3. So y1 divided by 19 is equal to 1 divided by 25. So I have y1 is equal to 0.76. y2 divided by 21. y2 divided by this span from here to here, this is 21. y2 divided by 21 is equal to 1 divided by 25. So I have the value y2 is equal to 0.84. So similarly y3 divided by 23 is equal to 1 divided by 25, or y3 is equal to 0.92. Therefore RA is given by load into ordinate. So RA is equal to 80 into 1 plus 160 into y3, 160 into y3 plus 150 into y2 plus 120 into y1. Substituting the values, we get the value 444.4 kilonewtons. This is value of RA. So similarly ILD for RB. Now place the loading system here. First, second, third, fourth. So 120, 150, 160, 80. Mark the ordinates. This ordinate is 1, standard value. Let this ordinate be y1, y2, y3. This dimension is 19 and all these dimensions are 2, 2 each. 2, 2, 2. I have to calculate y1, y2, y3. y1 divided by 19 is equal to 1 divided by 25. So y1 divided by 19 is equal to 1 divided by 25. or y1 is equal to 0.76. y2 divided by 21 is equal to 1 divided by 25. y2 is equal to 0.84. Similarly, solving for y3 you get 0.92. Now RB is equal to load into ordinate 80 into y1, 160 into y2, 150 into y3, 120 into 1. So I have 80 into y1 plus 160 into y2 plus 150 into y3 plus 120 into 1 ordinate. So solving this you have the answer 453.2 kilonewtons. So this is the value of RB. Now we'll go with the second step. Maximum shear force at section x is equal to 8. X is equal to 8, L minus x is equal to 17. So let this dimension is x is equal to 8. This dimension L minus x is equal to 17. Now to find shear force, you have to place the loads once towards the left, next towards the right. So first let me place the loads towards the left. 1, 2, 3, 4. So this load is 120, 150, 160, 80. Mark the ordinates. Let this ordinate be y1, y2, y3. Now before that let me calculate this. This ordinate is given by x by L. So x is 8, L is 25, 0.32. This ordinate is given by L minus x by L. So L minus x is 17 by 25, 0.68. Now similarly, in the next process, place the loads towards the right. So 1, 2, 3, 4. So first load is 120, 150, 160, 80. These are the ordinates. Let this ordinate be y4, y5, y6. Now mark the distances. So these are placed at 2 meters apart. 2, 2, 2. So this is 17. 17 minus 6 is 11. So similarly here. These are 2 meters apart. 2, 2, 2. This overall is 8. 8 minus 6. 2 is the remaining. So next I have to calculate y1 to y6. So we'll start with the calculations. 0.32. 0.32 divided by 8 is equal to y1 divided from here to here. y1 divided by 6. So I get y1 value. 0.32 divided by 8 is equal to y2 divided by 4. 0.32 divided by 8 is equal to y3 divided by 2. So 0.32 divided by 8 is equal to y1 divided by 6. So y1 is equal to 0.24. 0.32 divided by 8 is equal to y2 divided by 4. So y2 value 0.16. 0.32 divided by 8 is equal to y3 divided by 2. y3 is equal to 0.08. So similarly here for this term, this is 0.68. 0.68 divided by 17 is equal to y4 divided by 11 plus 2 plus 2. y4 divided by 15. So similarly 0.68 divided by 17 is equal to y5 divided by 13. 0.68 divided by 17 is equal to y6 divided by 11. 0.68 divided by 17 is equal to y4 divided by 15. So y4 is equal to 0.6. 0.68 divided by 17 is equal to y5 divided by 13. y5 is equal to 0.52. 0.68 divided by 17 is equal to y6 divided by 11. y6 is equal to 0.44. Now let us calculate maximum negative shear force. Maximum negative shear force is given by load into ordinate 120 into 0.32 plus 150 into y1, 160 into y2, 80 into y3. So I can write here 120 into 0.32 plus 150 into y1 plus 160 into y2 plus 80 into y3. So solving this, you have the answer 106 kilonewtons. So similarly, maximum positive shear force, these values 80 into 0.68, 160 into y4, 150 into y5, 120 into y6. So maximum positive shear force is equal to 80 into 0.68 plus 160 into y4 plus 150 into y5 plus 80 into y6. So solving this, you have the answer 281.2 kilonewtons. So 281.2, 106. Therefore, absolute maximum shear force is equal to 281.2 kilonewtons. Absolute means irrespective of sign. Now we will continue the next part. Maximum bending moment at section x is equal to 8. So this is a loading system. This is my girder. This is the point x. So let me call that as capital X. So x small x is equal to 8. L minus x is equal to 17. So I have to put a table like this. Load crossing the section. These loads, they are crossing the section from left to right. And I am interested in this point. So I want to know placing of which load will give me maximum bending moment. So load crossing the section, average load on AX. What is the load on this portion AX? Average load. So load divided by span, total load divided by span. Average load on BX, total load on section BX divided by span 17 remarks. So I have to confirm whether AX and BX, which one is greater. So first let me write 120. Let me assume that 120 crosses this section. So 120 is here, rest all three loads are here. So average load on AX, 120 has crossed, these three are remaining on AX. So average load is 80 plus 160 plus 150 divided by 8 span. So I have the answer 48.75. So similarly, only one load is on section BX. So its average load is this load divided by span 17. So 120 divided by 17. I have the answer 7.05. So compare this and this. So what I can write is AX is greater than BX. Now let me say 120 has crossed, now 150 has crossed. So 150 has crossed means these two loads are on AX, these two loads are on BX. So average load on AX is 80 plus 160 divided by 8. So I have the answer 30. Now average load on BX. So BX 150 has crossed. So 150 and 120. 150 plus 120 divided by 70. I have the answer 15.88. So compare this and this. So I can write still AX is greater than BX. Now let me assume third load has also crossed the required section. So 160. So 80 is remaining on AX. These three loads are on BX. So 80 divided by 8. 10. Average load on BX. 120 plus 150 plus 160 divided by 17. I have the answer 25.29. So what I can assume is, what I can conclude here is AX is less than BX. AX is less than BX. So I have to identify because of which load there is change in sign. This greater than has become smaller than, and that is because of crossing of 160 kilonewtons. So I have to place this 160 kilonewton load on the required section X. So I can write the conclusion. The change in sign is due to crossing of 160 kilonewton load. Hence, place 160 kilonewtons on required section. Now I have to place this 160 kilonewton load on the required section. 160. So before that 150 and 120 they are crossed. 180 is towards the left. Now place the loads in such a way. 80, 160, 150, 120. Now find ordinates for them. Now let this ordinate be, this ordinate is given by x L minus x by L. So x is 8, L minus x is 17, 25. So this is given by the value 5.44. Let this ordinate be y1, this ordinate is y2, this ordinate is y3. Now let me mark the distances. X is equal to 8. So these distances, they are 2 meters each. 2, 2, 2. This overall is 17. 17 minus 4, 13. 8. 8 minus 2 is 6. Now I have to calculate these ordinates. So here to calculate y1, 5.44 divided by 8 is equal to y1 divided by 6. 5.44 divided by 8 is equal to y1 divided by 6, or y1 is equal to 4.08. So similarly here 5.44 divided by 17 is equal to y2 divided by 13 plus 2, 15. 5.44 divided by 17 is equal to y3 divided by 13. 5.44 divided by 17 is equal to y2 divided by 15, or y2 is equal to 4.8. So similarly 5.44 divided by 17 is equal to y3 divided by 13, or y3 is equal to 4.16. Therefore bending moment at x is equal to 8 is equal to this ordinate into this load 160, y1 into 80, y2 into 150, y3 into 120. So I can write 80 into y1 plus 160 into 5.44 plus 150 into y2 plus 120 into y3. So solving this, you have bending moment value as 2416 kilonewton meters. So this completes the problem. Thank you.